Hello everyone. My name is Ingrid Berru, and I am under the supervisor, Dr. Renato Machota, and today I'm going to present a summary of my research. My research consists of the deployment of a low-cost GNS system at the COULEE LANDSLIDE located in the south of Alberta. I will talk about how the system works, the deployment process, and the preliminary results. How the Sparkfun unit works. The Sparkfun units use the real-time kinematic technique to enhance its position accuracy. But what do I mean by that? When the GNS system, for example, a base, is receiving the satellite signals to estimate this position, that satellite signals has some errors that the GNS system or the GNS unit, in this case, the base, cannot solve on its own. So the typical setup of the RTK system use at least 2 GNS units. One GNS unit known as a base, which coordinates we know, and the other known as a rover, which coordinates we want to estimate. Because we know the coordinates of the base, we can estimate what are the errors and what are the corrections. That corrections are sent from the base to the rover by radio. The corrections in our system are known as RCTM corrections. The rover receives that corrections, and in that way, we can estimate the position of this rover with a millimeter accuracy. In our system, we have 14 millimeter accuracy horizontally and 10 millimeter accuracy vertically. What are the principal components of these Sparkfun units? Is the satellite antenna here. We have the interface cable that is connected to the Sparkfun units. We have the radio. The radio allows us to send the corrections in the case that is a base, or receive the corrections in the case that a Sparkfun unit is working as a rover. And also here you can see a laptop. Why? Because I use the U-Center software to configure the Sparkfun units. Also, previous testers, we set the recording rate every minute. And also the U-Center help us to download the data in a CSV format that give you longitude, latitude, time, number of satellites, among other parameters. Where is the COULEE LANDSLIDE? The COULEE LANDSLIDE is located in the south of Alberta, near Lethbridge and Taber, specifically in the northern slope of the Chin Lake, adjacent to highway number 36. And the COULEE LANDSLIDE is comprised of 4 main units. We have a clay field, a glacial till, we have the bedrock, and within the bedrock, we have a coal seam. That coal seam is believed to be the principal responsible of the movements that we have observed in the area. Because of the movements, currently the LANDSLIDE is being monitored by GeoCubes. That is another GNS system. And in our case, we installed 1 base and 2 rovers. The base was positioning in a stable area across the LANDSLIDE, we can see here. And we select the position of these 2 rovers based on 3 criteria. The first criteria is that we have the largest displacements observed in that 2 rovers, in that 2 positions. The second is that we have available a power supply system. And we use the power supply system of the GeoCubes. And the other one is that if we have a clear line of sight between the base and the rovers. And why is that? It's because we send the corrections from the base to the rovers by radio. So we need that. Here I am showing a general arrangement how the base was installed. Here is the antenna of the radio in this corner. Why? Because I wanted a clear sight on lines between the radio of the base and the radio of the rovers. Here is the Sparkfun base. The Sparkfun base was installed inside this waterproof box. And we can see here the radio that's sending the corrections. We have here in the other corner the satellite antenna. And here you can see, not properly, not clearly, but is the antenna of the GeoCubes. And we are powering the system using the power supply of this pumping house. After we install this, the Sparkfun units, this base, we upload the configuration. And after a surveying process that takes between 2 minutes to 3 minutes, depends on how much time you want to do the surveying, you immediately you start sending the RCTM corrections to the rovers. Here you can see also a general arrangement. This is the rover 94-9E in this position, the landslide, and this is the rover 95-32 in this position, the landslide. We mounted the satellite antenna in this steel rod. The steel rod was embedded to the ground in approximately 70 centimeters. Attached to that steel rod, we installed the radio antenna about 60 centimeters above ground level. Why? To have a clear line of sight between this antenna and the base. Also, we drill the battery box, this battery box, to connect the cables of both antennas with the Sparkfun unit. As we can see here, this is the cable of the radio, and this is the interface cable. As I mentioned before, we use the power supply of the GeoCubes to power our system. So the power supply consists of a solar panel, 10 watts solar panel, 2 batteries, 100 ampere hours, and also a solar controller. We use this light plug to connect our Sparkfun units. In this light plug was connected to the charger controller. So it was the charger controller was connected to these batteries, and the batteries were charged by the solar panel. And after this, after we set up everything, we turn on the Sparkfun units. And after, I can say, maximum 1 minute, we start receiving the RCTM corrections. What that means that we start monitoring the landslide immediately. After we deployed the units and everything was working correctly, we scheduled some site visits with 2 main objectives. The first main objective is to know if the Sparkfun units are still getting the RCTM correction, so we have a reliable data. And the second objective was to download the data. So the first visit was conducted in December, and everything was as I planned. We have the RCTM corrections. We have 40 millimeters accuracy horizontally. And also we can download the data, longitude, the coordinates, and number of satellites, the time. However, in our second visit, we have an issue with the Sparkfun units. The Sparkfun units stopped receiving RCTM corrections between December 18 and December 19th. And also we were curious why. So we looked at the average temperature in the area. This is a weather station 12.6 kilometers away. And we see that we hit a really low temperatures in that time. It was about minus 25. However, still, if we didn't have the RCTM corrections, the rovers continue recording the data until December 26th. And the other rover, 9532, continued recording until January 11th. And why they continue, I think that they have some battery, so they continue until they run out of the battery. So after that, so I am presenting right now the preliminary result between November 18 to December 18. And here we can see how the horizontal accuracy is constant. So we have here a display of 50 millimeters accuracy. However, after this, December 18, the accuracy reaches about 30 centimeters. So because of the amount of data, because we set the recording rate every minute, it's not really feasible to work with that data in an Excel sheet, for example. So I create a Python code to process the data. So we only use the uCenter, download the CSV data, and we upload that data in the Python code, and the Python code gives you the graph, which parameters we want to know, for example, velocity, cumulative displacements, cumulative elevation, between others parameters. For example, here we can see the normal distribution. So I divided the data in three categories. Total, that was the raw data that we collected. The RCTM corrections, where I set threshold for the data. I said that only the data that have a horizontal accuracy of 40 millimeters and a vertical accuracy less than 11 millimeters was the RCTM data. And the other one, I use the hamper filter to filter my data. With that filter, I filter the outliners, so the total data. And we can see here, for example, the data without aligners and with RCTN corrections. And for the east, and we have a similar result for the north. So with the RCT no outliners data, this is the data that is reliable. So I conducted a filter process. I want to send Soras because he helped me, he supported me a lot with these estimations. So we can see here how the east coordinates is changing, but only is like 5 millimeters is the difference between for example, the lowest to the highest. And I use two window size, one window size of 1 day and the other window size of 7 days. So the black line is the window size of 1 day, and the yellow is the window size of 7 days or 1 week. However, it's not only like that. Because of the program, the Python code asks you which window size do you want. So we can use a window size of 1 month, 2 days, 15 days. It's just here I am presenting 1 day and 7 days because I only have the data for 1 month. And here is the preliminary result, the horizontal velocity of the rover 949E that is located in this area. So the purple is the data with the filter of the window size of 1 day, and the yellow is with the window size of 7 days. And we can see here, for example, the annual cumulative displacements on this for 1 day is 28.8 millimeters. However, for 7 days is 25.2 for this rover. And from the other rover 9532, we have different values for 1 day window size of 1 day, which was annual cumulative displacement of 13 millimeters. And for a period of 7 days, we have 8.2 millimeters. So we can see that, for example, the Sparkfun unit was working correctly for 1 month after we reached that temperature minus 30. So perhaps we can make it more efficiently to increase the solar capacity to 10 watts, perhaps to 50. So we don't have that that efficient in the power supplies. Also, we are using the XBP9X radio, and that shows us that we have a constant RCTN corrections. So we have a reliable data. Another characteristic of the Sparkfun units is that after the surveying, we can start sending the RCTN corrections, and the rover almost immediately capture that RCTN correction and start monitoring the landslide. And also, we don't need a third party, a third company to download the data. We can go to the site and download the data as we recover it and process the data. And for the preliminary results, but it's just preliminary, just 1 month, we have that the displacements in the landslide are kind of accordance to what was recorded in previous years. And I want to acknowledge Alberta Transportations, Long Clipper Berger, and my supervisor, Dr. Machota, for letting me present this and do this research. And also I want to thank Aiden and Katrina for helping me to install the Sparkfun units, even though it was minus 15 degrees. Thank you so much.
Time for a question. Yeah, you had shown there that it was within the 14 millimeter accuracy for horizontal pretty consistently, other than the one outlier. So would that lead you to believe that the accuracy is more like a 10 millimeter or?
No, the vertical accuracy I didn't show here, but also I have a graph of the vertical accuracy, the 10 millimeters. So I set that threshold. So it was like values, because I said 40 millimeters because it was like constant, like you can see. However, for the vertical accuracy, I have like between 10 millimeters to 15 millimeters. So I said values less than 11 millimeters is going to have that similar coordinates. So it was more reliable.
Okay.
Can you share why you went into building the Sparkfun when there were also the geocubes that you had tried before?
Yeah, exactly. It was because the GeoQs are more expensive than the Sparkfun units. The Sparkfun units are more cheaper. Yesterday, I kind of made a mistake about the cost, but now I have a really estimated is one pair, one base, and one rover it costs approximately $4,000. However, that cost can decrease or can increase depending on, for example, the batteries, which battery you are using, which solar panel you are using. And to add one rover to the configuration, it costs approximately $2,000.
And how many rovers did you have set up with it?
Right now, I had only 2 rovers and 1 base.
Have you ever considered like geo-fencing around those if you have accurate positions, so you could provide alerts based on like movement past a certain like reference point?
Yeah, I am kind of starting doing that process right now.
Okay.
Yes.
She's got them working. She's got them to the point where we can trust them.
Okay.
So we
No,
need to
yeah.
get them to the point where we can trust them when it's cold.
Yeah, there's some like
Yeah.
personal safety devices that work off the same concept. It's an interesting application.